Okay, today we are starting with chapter alcohol. So in this chapter alcohol is the continuation of chapter halogenoalkene. In chapter alcohol, we are going to learn the first one is structural characteristic. The hydrogen and oxygen is the characteristic of the alcohol functional group. It is called as hydroxide. Oxygen in alcohol is sp3 hybridized. Alcohol has bent shape like H2O. So this is the molecular shape and the hybridization. Let me ask a little bit to Natasha. Natasha,
Teacher.
do you still remember what is the bond angle for molecule that has bent shape? Bent, it is, or it is called as V shape.
Is it 90?
90, no, 104.5. And then,
Oh,
uh, the hybridization of sp3. Sp3, does it have sigma bond or does it have pi bond? Natasha, do you still remember?
um, is it sigma?
Yes, correct. sp3 sigma bond. Because the oxygen atom is electronegative, so the OH bonds are all polar. Okay. The meaning bipolar, it means there is a electronegativity difference between oxygen and hydrogen. Oxygen is very well known to be an electronegative element, while hydrogen is an electropositive element. Hydrogen has tendency to lose electrons, but oxygen has tendency to gain electrons. So that's why it is polar. And this one also explains why alcohol soluble in water. Okay, it is it is soluble in water, and the intermolecular forces between the molecules is called as hydrogen bonding. Okay, let me ask to Michelle. Hello, Michelle.
Yes, teacher.
Yeah, Michelle, I would like to ask, do you still able to recall about the temporary dipole forces and also permanent dipole forces?
Yes.
Yes. Okay. What is the difference between temporary dipole forces and permanent dipole forces?
Temporary typo forces are weaker
Yes.
compared to permanent.
Yes.
Um, and,
And which one is soluble in water?
temporary.
Temporary dipole can dissolve in water. It is not the permanent dipole forces. Temporary dipole forces, it is called, it is like the bromine. Bromine is temporary dipole forces. Okay. Now let's continue to this one. Nomenclature. Nomenclature is for naming the alcohol. Number for find the longest. So in order for nomenclature, we have to find the longest carbon atom, or called as the main carbon chain. And then next, the number the chain in a way that gives the OH group the lowest numbering. So example here, like in this structure. In this structure, as you can see on your screen, there are four carbon atoms as the main carbon atoms. And this CH3 is called as the substituent. And the functional group here is located in this carbon atom. From the right hand side, it is carbon atom number 2. So the name of this one is 2-methyl butanol, or 2-methyl 2-butanol. And then for this one, it is also the same. This one is called as the 3D. So there are 1, 2, 3, 4. This CH3 is located at the back here. This OH is in the front. This one, for the cyclo, the nomenclature of the cyclo is in here 2-methyl cyclopentanol. So we have to name here. Let's see the number 1. Where is the number 1? The number 1 of the carbon in a cyclo is located where the functional group attached. This one is attached in here. So the OH is attaching here. So the carbon atom number 1 is this one. And this one number 2. This is for the nomenclature. Okay. And then next, this one, how about nomenclature for alcohols in ring systems? When OH is bonded to a ring, the ring is numbered beginning with the OH group, meaning the carbon atom number 1 is for the OH group. The ring is then numbered in clockwise or counterclockwise to give the next substituent the lowest number. Example in this one. This one, there are two sides. One is the functional group, and the other one on the left hand side is the methyl. Methyl is the substituent. So the substituent must have the lowest. Since this is carbon atom number 1, so this one is carbon atom number 3. And then for this molecule, there are many substituents. This one, 2, and 3. There are 3 substituents and 1 functional group. Of course, the carbon atom that is attached to a functional group is called carbon atom number 1. So therefore, this one, the next substituent is carbon atom number 2. And this one will move 3, 4, 5. So therefore, the name is 2,5,5,3-methyl cyclohexanol. How about if it is the rotation is clockwise? Although it is clockwise, the substituent is the number is furthest. So it is not allowed. So it has to be, the substituent should be the lowest, the second lowest number. Okay. And then next, now for diol and triol. How come diol and triol? Where does it come from? If we recall from the chapter alkene, last I think one last month we studied about alkenes.
What is that doing?
Yes, Nathan V.
Okay. Hello.
Hello, Nathan V. Um, Last month we studied about alkenes. Am I right?
Mhm.
Yes.
Yes.
In the alkenes, there are two possible reactions. There are two possible reactions. The mechanism is only one. It is called as hydrolysis.
Mhm.
The first one is using cold acidified potassium manganate, and
Yes.
the second one is using hot acidified potassium manganate.
Yes.
Using cold acidified potassium manganate, alkenes will become diol.
All right.
With hot with hot potassium manganate, the alkene will hydrolyze into
Theo.
aldehyde, carboxylic acid, ketones, or also can form carbon dioxide.
I see.
Okay. In this one, this alcohol, there are diol and triol. Okay. So alcohol which possess two hydroxyl group are called as diols, and those with three hydroxyl groups are called triols.
Theo.
Yes, triol. And next, now before I go to isomerism, before we discuss isomerism, I would like to tell that in alcohol there are also called as primary, secondary, and tertiary. The rule is the same as the halogenoalkene. So we have to observe the number of hydrogen of the carbon that is attached to the hydroxyl group. Okay. Next, isomerism for alcohol. The isomer of alcohol, there are the mainly the structural isomers. There are three components of structural isomers, which is the positional isomer, chain isomer, and also the functional group isomerism. The functional group isomerism of alcohol is an ether. And this one, the positional isomer, and also can alcohol can undergo stereoisomerisms. The stereoisomerism it could have is only the optical isomer. It does not have the geometrical isomerisms. Okay, so in here there is a positional isomer for 2.2 dimethyl propan 1-ol. So the positional isomer can be pentanol, can be 2 pentanol, 3 pentanol. And then also with positional isomer of this one is also made up of pentanol. So 3-methyl 1-butanol, 3-methyl butan 2-ol, or 3-methyl 2-butanol, and then 2-methyl 1-butanol, or 2-methyl butan 1-ol, and then the last, this one is 2-methyl butan 2-ol. Why there are so many positional isomers? Because there is a functional group different from alkenes. Alkenes do not have so many positional isomer because they because alkenes do not have functional group. Okay. I have some question here. Let me ask to first to Eric. Hello, Eric.
Yes, teacher.
Eric, does pentan one all or pentanol, this structure, have optical isomerism that I circle with red? Is there
Mm,
any optical isomer?
no.
Yes, correct. Thank you, Eric. Now, next one. I would like to ask to Sharon Jessica. Oh, Sharon Jessica is. Hello, Sharon. Are you there? Okay. Sharon Jessica. Oh, let me ask to Lawrence. Hello, Lawrence.
Yes, teacher.
Lawrence, I would like to ask whether this trimethyl butan 1-ol have enantiomer. Is there any enantiomers for trimethyl butan 1-ol?
Mm,
Do you remember what enantiomers are?
mm,
Okay,
no, teacher.
enantiomers is the optical isomers. Is there any optical isomers for trimethyl butan 1-ol?
Yes.
Are you sure, Lawrence? In trimethyl butan 1-ol, this one does not have optical isomerism. Okay, it does not have.
Okay.
Okay, let me ask to Ariela.
Yes, teacher.
Ariela, can you help us to state what are the isomers on the screen that has optical isomer?
Um, 2-pentanol.
2-pentanol, yes, it has optical isomer. And then,
3-methyl-2-butanol.
yes, is there any other?
2-methyl-1-butanol.
3, 2-methyl butan 1-ol.
Oh, yes, 2-methyl.
Yes, yeah, or 2-methyl 1-butanol is the same.
And I think that's it.
Yes, correct. Thank you, Ariela. So all this 1, 2, 3, they have optical isomerisms, while the others cannot. Then others do not have. Example like this one. This one, the molecules of this one is the same left and right. If they are the same, of course, it is not chiral center. Okay, so what are the synonym for optical isomerism? What are the synonym? The synonym first is, does the molecule have chiral center? If there is a question, it means the question is asking, is there any optical isomer or not? And then the second, is there any enantiomers? Because if a question asking for the presence of enantiomers, it means there is a cell center, whether there is cell center or not. Okay. Now, let's continue until here. Is there any question? Tisel, Vanessa, Atta,
No
Patrix?
questions, teacher.
No question. So I will proceed. Now, physical properties. Of course, without knowing the physical properties, how can we discuss directly the chemical properties? So, what are the physical properties? Alcohols consist of non-polar and polar. Where is the non-polar? The non-polar is the alkyl groups, or called the alkene-like non-polar. And then the polar, here it is the OH. Thus, alcohols might be water soluble and or not, depending on the length of carbon atom. And the boiling point of alkenes increase with the boiling point of the chain length. What does it mean? It means that the longer the alkyl group here, longer the alkyl group, the alcohol will become insoluble. And if the shorter the alkyl group, example, only one carbon atom in the alkyl group, then the boiling and melting point is low. Okay, and then wait. Okay, the boiling point of alkenes increase with increasing chain length. Alcohol with more than one hydroxyl group have higher boiling points because there is one hydroxyl group. It means it has more than one hydrogen bonding. Okay, if it has more than one hydrogen bonding, then the strength of the or the ability to dissolve is greater. Okay, next, the physical properties. Also, the solubilities depend on the length of the carbon chain. Soluble due to hydrogen bonding. So in here, the number of carbon atoms, if we see from here, the number of the carbon 1, 2, 3, 9, and 10, the boiling point increases. And then this one, the solubility of water in 100, solubility in water at 25 degrees Celsius per 100 milliliter of water. This is completely soluble. And then as the more carbon atoms, it will decrease. Okay, decrease, I think the decrease is exponentially. Wait, let me eh, okay, next, as discussed, we still have 15 minutes. And then for physical properties, alcohol versus alkenes of the same chain length. Of the same chain length, this one, alcohol will able to dissolve. What is the meaning by this dotted line? This dotted line, it means the formation of hydrogen bonding. This is how to draw hydrogen bonding in alcohol molecule or alcohol with water. This is the hydrogen bonding in water in alcohol molecule. Why is it alcohol? Because in here is written R groups, R groups, R group. Okay, so what makes them dissolve is the hydrogen bonding, not the alkyl chains. Okay, and then next, classification. Alcohols may be classified as primary, secondary, or tertiary. Depends on the carbon bound to the hydroxyl bearing carbon. Okay, so like just like I told you earlier, just like earlier that I told you that this one we have to see the number of hydrogen attached to the carbon hydroxyl. So this one is called as the primary. This one, if only one alkyl group attached, it is called as primary. If there are two alkyl groups attached to the COH, it means it is secondary. And if there are three alkyl groups, it is called as the tertiary alcohol. Okay. Next, chemical. Now the chemical properties. For the physical properties, is there any question? Let me ask to Tisel. Hello, Tisel. Do you have any question? Hello. Is my internet have problem, or does my internet have problem, or am I out not audible?